Good morning. My name is Tim Toole. I'm from Sandia National Labs out in Albuquerque, New Mexico. Today we're going to kind of walk through a little bit of a story on how we've used Faucet in one of our development environments. I like to call it, it's our production development environment, so to speak. But we'll kind of walk you through kind of how we've acquired some hardware, kind of got involved in utilizing Faucet for doing cloud testing and development. A little bit about Sandia. If you're not familiar with, it's a U.S. Government laboratory. It's a federally funded research and development center, which basically means that we're not supposed to be competing with industry, but it is a government-owned, contractor-operated organization. Two main sites. There's about 13,000 in Albuquerque, New Mexico, and there's about another 1,000 at one of our satellite sites that's just to the east of here, about an hour, depending upon traffic, Bay Area traffic. Wide-ranging missions from nuclear weapon stockpile, deterrence, security, energy, and a lot of national security programs. So the group that I work with, and then there's two of my colleagues here today. We represent a relatively small team of folks that do a lot of work in virtualizing cloud environments. So VMware, OpenStack, et cetera, whatever the kind of the neat virtualization technology that is hot these days. It's basically doing a lot of basically building these environments and then sort of testing how we would sort of use them, what risks they pose, what sort of advantage they have, and we sort of advise our more operations side of the house is like, and here's where we think technology is going to be viable or something that we can use. Got a lot of experience again with mostly virtualization technologies. My background's a little bit more and kind of on the networking side, which is why I get to be the Stucky given the talk. So a little bit more about sort of building the cloud environment. So if anyone has ever built out, done like a Kubernetes installed by hand or an OpenStack installed by hand, or basically done a lot of the stuff from the ground up, you realize there's a lot of moving pieces. There's a lot of different network connectivity, and the orchestration process is quite complex. So we wanted to be able to build in parallel a lot of these environments, but like a whole cloud environment as a single tenant. So normally where you'd think you'd have one cloud environment that has sort of one management or administrative plane, and then you're gonna have multiple users being different tenants. We're gonna build a whole cloud environment and call that sort of Cloud Tenant A, Cloud Tenant 1. So that way, one of the folks on our team can do their testing, whatever, and that test can be completely isolated from another researcher in our group who has a completely different setup and can do their sort of testing and so forth. But we also kind of going into this knowing that we could probably use Faucet and some of the features of software controlled network to kind of put on some ownership on ourselves. We wanted to kind of try something that hadn't been done before, try something new and novel, and then sort of put some requirements on ourselves to have this different mindset about the way networking can be done and networking should be done, in today. So we gained a lot of inspiration. I think that's probably the right word to describe. So those that were involved in the Supercomputing 18 network, it's a lot of kudos to that team that pulled that off. This is a multi-vendor, Faucet-controlled environment. It was production quality. It was stable. It gave them statistics on the network, so they could kind of see how the health and monitoring was. And it also gave them the ability of doing some monitoring. So you'll hear following me following my talks, you'll hear stuff from the Poseidon team. And so that's some health and monitoring. So some analytics that are built in, gives you the ability of building in, I think are incredibly powerful. So that environment that was set up there at supercomputing, given the fact that they put this wonderful diagram out there and the configs, that's kind of the starting point. So we can kind of take what the network looked like, all the port mappings, and then sort of match them up with the configurations. And this was sort of where we started on this endeavor of using a very dynamically reconfigurable network to use for our purposes. So kind of like probably a lot of maybe greenfield environments, you start out with talking with different vendors about feature sets and what we think is going to be needed. I'll be honest, my shopping list was relatively small. It started with the list of proven and tested vendor equipment from supercomputing. What do you want? Local present input. Jay. Who's Jay? Kick Jay off. It's Joe. Thank you. So after after a number of different phone calls and getting some equipment in, we had kind of like we had a sad Arista day in our lab. We had been primarily very much a legacy networking gear from Arista. The stuff has gone through numerous, I would say, AC failures in our lab where temperatures got ridiculous high, and those things just kept cranking, chugging away. So it was pulling them out of our lab, piling them up. We had a pile of probably about eight Arista switches that we took out of production. It was definitely like a sad day for us. Maybe in the future we'll look down the path of integrating some new Arista equipment into our network, given the success from yesterday. But those three switches up there, those are the ones that we sort of settled on, and I would sort of bucket them in sort of the category of there's always going to be a need for sort of like copper single gigabit Ethernet in our network. There's going to be IPMI interfaces. They're going to be slow plane communication, slower, less than 1 gig. So we had to have a number of inexpensive switches that would give us some of that connectivity. But then, of course, on the higher throughput, we were using Allied Telesis and NoviFlow edge core. So going back to like what our approach was at the time, again, we want to build out multiple separate cloud tenants, and then basically as we decide to image a cloud tenant, create it using Cobbler, we would sort of configure Faucet for how we want the networking to look for that particular experiment. We'd SIG hub the process, and then we'd start imaging the metal. We wanted this goal of having 100% SDN network too. Every port I wanted to be a Faucet controlled interface, and I'll talk a little later about why that was not a smart thing to do. Shooting yourself in the foot. So our process is number one, starting from, if you imagine, from sort of like a greenfield environment, connect everything, connect all the ports up. Knowing there's this notional concept of sort of a fast path and a slow path connectivity of the 1 gig connections versus your 10 and 40 gig. So we just wire up everything, keep really good notes, and that was kind of our Ansible inventory. It's where we know where all the physical links are, and this will come into play later. This is the ground truth. This is exactly where physical links are. We're not going to be able to push packets over a non-connected device. So now that we had a map, a physical map that was in our we'd create a playbook. So we have the inventory, we can create our playbook. We can then basically go out and deploy a very simple config based upon, right, all the documentation for Faucet, how we're going to do it. And this would give us, we'd kind of create our own separate VLANs. We knew that which VLANs needed connectivity to each other. We could then push layer 3 rules up to our virtual router that would do routing if it was a requirement. And we had connectivity, and it's a very straightforward, simple, scriptable process that gave us essentially that full tenant isolation. So this is our first. This was our first iteration of our network. On the right-hand side is kind of like our infrastructure clouds. We use our own little cloud for providing typical services. This is like, for those of you who were yesterday, your DHCP, DNS, your IRC server. It's all those basic services that you have to have. And GitLab is also now part of our deployment operation model as well. So that's kind of the foundation where we keep all our master logs, and we can generate GitLab runners to run off and do other little worker processes in our network. I will say the other notable thing from the diagram is we have kind of the concept of our corporate network. Everything inside our lab environment is all private IP space. And then if in fact we actually need to get out into a corporate network, we've got a NAT firewall that can handle that. But for the most part, all the stuff stays contained inside this network. So the next step in this is layer 3 stack routing, and this is clearly where the benefits of SDN come into play, about choosing paths, optimal paths, be able to just add devices into a network and everything magically happening. And I'll say this is where the fun began for us. It's also where we learned a lot of lessons about integrating hardware into the network. And in terms of like how we define a network topology and how we set that layer 1 stuff up, it still goes to I think our traditional mindset of we all kind of know roughly in a cloud environment or particular environments about what the use case is going to be and where data is going to be moving. So we use that as kind of an influence, but it wasn't we weren't like tied to that one. So we started following this process of creating a series of test scripts, and the test scripts go back to sort of the ground truth of where physical connectivity was in our network. So we have one script that says make network, and that is exactly how the human connected all the cables to the switches together. So we're using Open vSwitch for doing all our links, our stack port links, or trunk port, or whatever you want to call it. Just basically, it's a physical link between one data path or another. The make network, that's all it does, and that's all it's going to do. It follows the same bash RC scripts that Brad and Josh wrote and whoever else wrote as part of Faucet. It's just a very simple script. But the nice thing is that now I know that we've validated our physical connectivity with that script. Next one is just making the hosts, and that's just a simple, I would probably say add some sanity to how we believe packets need to be tested across an infrastructure. So we did yesterday, we brought this small little Intel NUC devices so we can just do end-to-end connectivity tests across them, or the Commodore 64. So this is kind of how we'll just create a namespace on there with an address and maybe a service, or not so much. Maybe just it's an IP stack that can kind of give us that test. And then what the tests actually consist of is purely kind of discretionary, depending upon what we want to do. Sometimes it is an IP stack. Sometimes it's going to be the fact that a packet doesn't make it to its endpoint is what we're looking for as well. So we just do a very simple little end-to-end test, and then we just kind of again script all that together. So now when we run this whole process, it follows how we physically connected the network together, how we think we want to do our end-to-end tests, and then the test itself. This is where we ran into hardware problems. So this is now taking, for every step forward, you take a couple of steps backward or something like that. And we ran into these OpenFlow ePerm errors continually. And so after a lot of back and forth, with Brad and Josh and some few other minds, Josh says, "Oh, there's this wonderful little thing in the documentation that says how to debug OpenFlow on an Aruba switch. You should check that out." Oh, there's Chris. Our lesson there is read the documentation. I would argue that debugging OpenFlow message on an Aruba out to console isn't the smartest thing, especially if you are connected to a serial port. We've kind of gone to the model of once we configure our data path or switch, we don't touch it again. We don't log into the switch ever again. We're done with that. We want to do everything from sort of the Faucet controller. But this is one of the occasions where we realized, hey, what we should be doing is probably doing Syslog on OpenFlow error messages off the device back to a Syslog server. So, if you're from the networking world, SNMP was kind of like, sort of the usual thing. Now we're going back to Syslog. So it's basically Syslogging everything. So we added a Syslog to the server to the network. And now we can get a little bit more understanding, and we started PCAPing a lot of that OpenFlow 1.3 channel as well, so that we could see what type of messages were coming back. A lot of times they're truncated because you're going to get encapsulated packets in an OpenFlow message, but the Syslog kind of covers a lot of that stuff. We'll note it took me a while to understand what a TFM was. Look, grepping through the code base, I never saw table features message in one word, like one phrase, and it was thrown around a lot, and now I throw it around a lot now that I know what it is. So just as understand, it's part of the a feature message. It's an OpenFlow spec message, so it's just one of those things that I think is probably an integral part of understanding sending table features messages to switches and data paths, getting back and then using that control channel for understanding how a pipeline is configured on a data plane. So we so after a lot of that stuff, we got this wonderful little feature that Josh introduced, which allows us to do some scaling back of some of the the resources that are going to get consumed off of an Aruba. And we're back up and running. And so we have routing going. We've got a full layer 3 stack. We just turn on one simple little feature in our Linux router that knows about the whole /16 on the right hand side. And if again, we need routing resources in our corporate environment, everything works. This is not too different from probably the way we architected things yesterday. In our Plugfest. So going down sort of a few different lessons learned. Without a doubt, getting up and running a network is a very, very simple process, even with hardware. At least it was for us. Obviously, we ran into a couple of hardware glitches, but Open vSwitch. I'm a big proponent of doing a lot of software testing. It's a fantastic production quality switch. Gets you 90% of the way there. The stuff that it can't handle is going to be a lot of those small edge cases. Our Allied Telesis stuff I think we've only power cycled it once in probably the last 6 months. And it has been a fantastic core piece of our hardware. I think starting small, and we tried starting small and then starting in adding features and then taking away features and then adding them, see what the cause and effect is also a good lesson for, I think, for others. And another key thing is to kind of keep an open mind about networking. This presentation by Stephen Stewart, I think was a fantastic YouTube video for people to watch. It gets you, if you go into listening to that about how the network may not actually be doing, or may not, there are attributes of network traffic that may not actually be necessary to have a network up and running, and that's something that, coming from a networking background, might not be an easy thing to grasp, but knowing that you end up with a very efficient infrastructure, efficient and stable infrastructure. So broadcast traffic, ARP, stuff like that just operates differently in an SDN environment. Helps you appreciate the power of something like an SDN network. And most certainly don't run your controller off of a switch that's Faucet, that's SDN controlled. You end up with telling yourself, what the hell did I just do, and how do I get out of this scenario? Again, wanting to have a fully SDN environment, probably need to rethink that sort of mindset, and maybe have one switch port that we think we can do it with one switch port, and everything else can be SDN controlled. But we'll shoot ourselves in the foot a couple more times learning that lesson. Lots of good documentation. I think the Faucet OpenFlow switch pipeline page is incredibly useful. It's one of those things that I would say is worth learning and reading continually. Vendor-specific implementations, documentation that they have, also I found very useful. We were joking yesterday because I have on my iPad all the vendor documentation that's readily available. I kind of reference it time and time again. Specifications sheet, and then diagrams. I'm very much a visual person, so seeing those diagrams and seeing the configurations and aligning them was super helpful. So we started creating our own repositories that sort of illustrate how we would implement a certain feature of Faucet in our lab. Collect logs, PCAP, debug OpenFlow. It's another big lesson. Save all your configs, your Faucet log files. Roll them over. Follow a software development mindset. The concept of doing a staged approach of testing stuff, examples out using like Open vSwitch, doing small tests and larger tests, and then push out to your deployments. And then yeah, when I met Brad in April at ONS, I remember him saying this statement that rung true about learning a lot more about hardware, vendor hardware architectures than I expected to, about just digging into the bowels of switching architectures. And I don't think it's a scary thing. I think it's I find it kind of exciting, but it's definitely learning a lot about hardware limitations if this is the way we're going to be building networks. So our current status, we have about 300 physical interfaces set up across about 4 or 5 different switches, stock layer 3 routing model. Our network is incredibly efficient and quiet. I think it's one of the, and reconfigurable. I think it's one of the things that we're most happy about, is if we go into our lab environment and we want to do any type of wiki editing or any development stuff, it's so much more efficient than if we were sitting like in our corporate environment desktop system and kind of doing stuff on the corporate supported network. It's just it's been fantastic. We're almost, like I said, we're only have about 7 traditional or 7 legacy switch ports that are not Faucet controlled. We have now a full out of band management one, with the exception of probably our Grafana Gauge and Prometheus and Grafana, which is kind of doing all the collections so that we can kind of view the logs and everything like that. There was a port table scale factor feature that was just recently introduced, probably like 2 weeks ago. We have a smaller hardware test bed for where we're having our more troublesome hardware that we can do our testing with. I feel bad for my team, because every time we get a production quality, like stable infrastructure. I say we're going to go tear it down, we're going to go rebuild it, we're going to do something else that's kind of wild and crazy. And we're kind of now going through this re-architecture again of concept of maybe high availability and low availability parts of our network. And that's just because there are parts of this network that we cannot go down, and there's other parts that absolutely can go down. And that's and so we want to be able to do different types of architectures and scenarios because of that. Writing our own REU app for collecting OpenFlow messages. That's mainly just to kind of get a little bit more health and monitoring off of how the pipelines are configured in each of the data paths, as well as any other like OpenFlow message communication that we thought was going to be valuable for current status of our switches. And then I think there's a lot of cool features, potential, and growth with Poseidon, and that's something that we also want to spend a lot of time working with. So this is what we've this is where we're going down our next step. This is probably step 3 in a 10-step process, and the growth of our infrastructure. So we have two sides of the network. One's our development and testing network. So we've got dual controllers there. And then our stable side and dual controllers there as well. They have both a out-of-band management and data plane path back into the Allied Telesys, which basically is sort of the core of our high availability network. And then we have a traditional routing segment that goes over into our multiple cloud tenant networks as well. So that's where we do mostly all of our development and testing stuff. And we have 95% of this stuff done in our test environment, and it's now just a matter of going in and recabling everything the way we want, and then pushing configs out. So once we get the physical connectivity, we should be done. This is my little test bed at home. This is what I run at the house. It's a Raspberry Pi 4 cluster, Faucet controlled, not pictured as a controller. It's off on another part of the network, but this is a little playground I get to play with at home. A lot of thanks go to Nick. So thank you very much. I appreciate it. Pushes me to engages me and makes connections, push me to kind of go down this path. Brad and Josh, clearly you guys have been fantastic. There's a bunch of other Faucet developers and team members that I've met yesterday that I probably haven't met. I see, right, Chris is on the called in as well. Thank you all very, very much. I really do appreciate all the code commits, the organization. Thanks to Google for hosting all of this. Greatly appreciate that as well. It's very kind of them. Open vSwitch team. So they probably don't get the thanks that they deserve, but some fantastic work done by Open vSwitch. And then my team back home, who've put up with me breaking things continually, typically on a Friday when I'm not in the office, and ask somebody else to go redo what I just broke. So thanks to all of them. And that's all I have for you. So it's been a wonderful journey for us, incredibly positive. Minor blips that I think we would typically expect when trying to deploy something radically different. But I see a lot of good, really good future uses of it as well, certainly in our environments. So with that, I'll open it up to any questions. Yes, sir.
What kind of workloads do you run on this?
What
kind of workloads do you run on this network? And what do you intend to get out of this once this is fully operational?
So the question is what kind of workloads do we run on this, and what do we expect to get out of this? For the most part, it is not the workloads that we're trying to do is more more feature based, not throughput based. So the concept, we'll never saturate. I mean, I don't know if anyone's going to saturate a Tofino chip, but less than 10 gigs generally. It's not pushing a high amount of data. We only have one case where we will try to simulate a good portion of our workforce and then test a corporate application, right? So we want to simulate, I don't know, what's good ones, like, right? We do like a lot of like web streaming internally. So like president of the lab will give a talk or something like that. And a lot of times our video streaming service will just kick out. So off hours, we'll do maybe a load test on against that. That's only our heavy case. Most it's more like feature based in what, something that VMware has produced or something like that. We want to look into. So once we get the test, we can kind of go back to whoever the developer of the application is to sort of fix that or see whether or not that feature is something we want to incorporate into our corporate roadmap. Yes.
You said that you don't get afraid to dig into the switch architecture. So, OpenFlow is supposed to be vendor.
You're gonna scare me here.
So, what kind of adventures did you have?
What kind of adventures did I have with switch architecture?
Yeah, why do you need to actually look at it? We should, in theory, have your controller as long as you know your speeds and scale of the device.
This is a setup. It's because one vendor had hardware limitations, and so not all of them were created equally. That's why. Yes, Josh.
For your colleagues running, what's in theory? What's their impression of what you're doing?
So we have they don't know about it yet. We've had a couple of meetings on the books that have been sort of pushed off. My thought on that is we want to be sort of the go-to team that knows every intricate detail of how this works, how to troubleshoot it, how to operate and maintain it. To be able to work out, I think, a lot of those details, so that when that meeting does come to looking at maybe can we push this into our production, our sort of corporate environment, it's less scary for them, and thus we have the answers right off, answers and technical solutions too, right off our fingertips, so that they say, well, what do I need? Do I need, how do I integrate this in with our trap collector, SNMP trap collector? No. We're gonna set this up, and here's how we're gonna do log analysis and everything like that. Here's how when something fails, this is how you debug it. We're gonna have to retrain a few folks, but we haven't gotten to the point where I think we're comfortable enough to say we're at a scalable size that it's going to be attractive for them to say that we're going to be able to take this part of it into operations. Yes, ma'am.
Very interesting. On the other thing, foster basic logs from years.
So other than like the performance stuff, are there other features from the vendors that we would be interested in looking for? I think the only thing I can think of off the top of my head really comes down to logging information, logging ability, to know when something, when a configuration is done, we've pushed a configuration, we're getting the good response that it was executed correctly, and then here's what the result of that is, the configuration. Mostly, certainly on the pipeline side, when errors are, we get a lot of debug information out of the error aspect of it. Because yes, I think for the most part, and certainly an OpenFlow network, it's supposed to be sort of vendor agnostic. So when a problem does arise, I want as much debugging information as possible. Any other questions? Great. Well, thank you. Oh, one more. Yes.
So on that, do you see a need to try and get agree on some other stuff? how do they report these errors to you? Or is it fine having different debugging for different vendors? In a perfect world, would there be other things in common, or do you that it's okay to have?
Yeah, honestly, I kind of feel like that's like going down a philosophical discussion. I don't know the answer to that.
Has it been an issue for you having multiple vendors, like going from
I think the biggest thing is it's probably we all run into it, right? Vendor A wants to charge like $1,000 for an SFP or something like that, and in a small lab environment, Twin X Copper is awesome. Interoperability in that sense is always the thing, but I mean, I get the reasons for it, and but in terms of the event aspects of things, I don't know. I don't know if I have a good answer to that. Okay, thank you very much.